Good evening, professors. I am Kushagra Porwal, final year M.Tech student. I am presenting my master's thesis on leveraging sentimental analysis for domain-specific and social use cases. We want to leverage learnings from computer science to gauge public opinion towards an event, organization, or an individual. So, it's an area under NLP which is used by organizations and governments to assess a business decision or a policy change. So, based on the results, they can recalibrate their decisions or policies to garner increased business growth or a greater public mandate. So Twitter we are using as a source of data because people from all age group voice their opinions, and Twitter provides a wide range of APIs through which we can scrape a lot of data, which is available. Uh, if we talk about the broader classification, basically sentimental analysis is done using ML based or lexicon based. In lexicon based, we have two built-in implementations like text blob and weather. In ML based, basically we are focusing on supervised learning, where we are having a data set, we are labeling it, then we are training our model using that data set. So in neural networks, we are using bidirectional LSTM to create our model. Now, this Twitter Roberta based model, it was trained using 58 million tweets. The training is done in a self-supervised fashion. That means there is no labeling data set which was given to it. It is pre-trained with the MLM objective. So we masked 15% of the words, and the model has to predict those number of words. So the advantage is it learns an internal representation of the language and extract features from the text. That features can be used to train any standard classifier if we have a label data set. Now it is this particular model is presented by Cardiff NLP group from Cardiff University, and it returns label 0, 1, 2 as negative, neutral, and positive. XBlob we are using to compare our results. So it returns polarity and subjectivity. Polarity is in the range of -1 to 1 as float, and subjectivity, if higher subjectivity is there, it indicates opinion is personal in comparison to factual. Similarly, Valence Aware Dictionary and Sentiment Reasoner, it is basically relies on a dictionary that maps lexical features to emotion intensities known as emotional sentiment scores. So the sentiment score of a text can be obtained by summing up the intensity of each word. So based on the compound value it returns, we basically decide whether the sentiment is neutral, positive, or negative. Now, LSTM. LSTM is a type of RNN. RNN suffers from vanishing gradient problem. That means the fifth word, which when input to the model, it doesn't remember what was the first word. So in applications like sentence completion and all, or sentence classification, we use LSTMs. So if we talk about a generic LSTM cell, so how does it work? Let's take an example. So for example, we want to forget the old memory. So what we do is this particular sigmoid function has to generate a tensor of zeros. Then only it will be when it will be multiplied with this older memory ct minus 1, it will produce a 0, and only the new memory will be into effect. So this is the initial hidden state, this is the vector representation of input, and this is the new hidden state, and this is the new memory, and this is the output. So we do a weighted sum of ht minus 1 and xt, and we pass it to our sigmoid function, and we pass it to our tanh activation function, we pass it to the sigmoid activation function. The results from this and this are multiplied and provided as a new memory. This new memory is again fed to the tanh activation function, and this particular output from the sigmoid box, when multiplied, will give the new hidden state. A bidirectional LSTM, every word in the sequence is aware about the past as well as the future words. So it gives more accurate results, but the training is a bit slow because sequence is encoded both in forward and backward directions. And the problems we are taking it, Broadcom's takeover bid to acquire Qualcomm, which was blocked by Donald Trump, citing national security reasons. So we are doing sentimental analysis to predict sentiments towards Broadcom, Qualcomm, and Donald Trump. We are also doing public sentiment towards major semiconductor companies like Qualcomm, Broadcom, AMD, and Nvidia. We are doing exploratory data analysis on a lot of semiconductor companies. We are building a bidirectional LSTM model, which is trained using Ukraine-Russia war dataset. We are creating a function through which we can determine whether a user on Twitter is an influencer or not. So design. Data collection, the first approach we are using is Twitter search scraper, which takes a keyword, start date, end date, and then we are writing it into a data frame. User Twitter's developer account, we generated these keys, we authenticated, created an API object here, and using search tweets. and cursor as a pagination, we are actually collecting a lot of tweets and writing into the data frame. Now, basically, how we are using Roberta model, we are importing the model through this pipeline function. We are cleaning the data set here. We are converting everything into lowercase. We are removing all the URLs here. Then we are passing our tweets into the sentiment pipeline, which we imported, and fetching the sentiment labels and sentiment scores. Then we are recoding our sentiment labels as negative, positive, and neutral. Similarly, EDA, how we are doing, similarly, using TweetPy and these keys, we are authenticating and authorizing using this API handle. We have this get user function. When we pass any user screen name, that means a Twitter handle, we can do a lot of things like followers count, created at, favorites count, we can fetch and analyze. So we'll see it in the results section. Now bidirectional LSTM. So here we are using 4 kinds of data sets. So this first and second we have scraped from SNS scrape, 1 lakh tweets with the keywords Ukraine and Russia. Third and fourth we have pulled it from Kaggle as an open source data. We are using Keras to build our model. Keras is nothing but a neural network API to TensorFlow to create ML models. So we are loading the data set into data frame. We are dropping the columns which are not useful. We are removing rows, non-English rows, and data cleaning engine. It is removing all the retweets in that tweets, RT at the rate mentions, all the URLs, all the special characters from the tweets, converting everything into a lowercase. Also, we are removing all the stop words from our tweets because that also doesn't play any role in the sentiments, like you have, after this, which. Then basically data set is there, we have to label it. So we are using 3 ways: text block, weather, and Twitter Roberta based model. After that, we are intelligently reducing our data sets. Like in Ukraine dataset, I do not want any tweets which mention about Russia, Vladimir, or Putin, so that there is no collision in the sentiment protection. After that, what we found out, the data set was not balanced. So we tried to balance it with using random downsampling and random oversampling. So what it does is, so downsampling, it downsamples 2 classes to the size of the least sized class. Similarly, vice versa for random oversampling. Tweet text normalization. So basically, we cannot pass the direct tweet to the ML model. So we are tokenizing it, stemming it, lemmatizing it. Also, we are encoding our target variables to 0, 1, 2 so that the model can understand it. We are then having a train test data split, and then from the tokens we are fetching features using bag of words. Then we are tokenizing it into integers, and using padding sequences, we are actually making the input vectors of the same size so that we can feed it to the ML model. Then we are having the final train test data split. In the building bidirectional model, we are importing all the layers from Keras, and we are using these hyperparameters. So we are using SGD as an optimizer here, and it's a sequential model. All the layers are stacked up, and every layer has exactly one set of input and output tensor. And embedding layer is used as a hidden layer, which is actually mapping the higher dimensional space to a lower dimensional space, because vocab size is 5,000 and embedding size is 32. Also, max length is 50. That means 50 feature vectors are being encoded at a time. Con1D is actually producing a convolution kernel, which when convolved with input layer, basically produces a set of tensors, which is then fed to this ReLU activation function. Then we are using max pooling 1D. That means we are using a 2x2 window in a feature map to basically find the maximum value out of it, and basically to pass only the relevant features to the next layer. Then we are using bidirectional LSTM and dropping out 40% of neurons randomly so as to prevent overfitting. And then we are using this last layer as the dense layer, that is the learning layer, and using 3 because there are 3 outputs, positive, neutral, and negative. In the compilation model phase, we are using categorical cross entropy and batch size as 64. That means every epoch we'll take 64 samples, we'll calculate loss, biases, and weights will adjust, and we'll use it in the next phase of the learning, that is the next epoch. Then we are saving the model, and then we can use it later on for our predictions. We are also creating a function to tell whether a user is an influencer or not. So we are getting username as the parameter here, and then from get user we are fetching the user object. From followers count we'll get the followers count, and basically we can define any precondition here to decide whether a user is influencer or not. We are also handling a lot of errors, like if a user has been removed or it was a bot. If we could not found error, so we are handling those kind of exceptions. If, for example, we are not having permissions to fetch the details of that user, then forbidden we are handling. And then too many requests. That means basically Twitter actually imposes a lot of rate limits. So we are handling that in this third exception. So results and insights. So what we found out that using this Roberta based model, neutral sentiment and positive sentiment was highest towards Qualcomm. Negative sentiment was basically highest towards Donald Trump, and people were not very negative about Broadcom, if not extremely positive. In the text blob, through text blob, in that first problem, Qualcomm Broadcom acquisition, we found out people are neutral towards Qualcomm. People were most positive towards Donald Trump in terms of the percentage. That means people were liking his idea of blocking the deal based on national security, and people were most negative towards Broadcom. Then we did some bigram, trigram, and topic modeling analysis for Qualcomm. Second problem was public sentiment towards four major semiconductor companies. What we found out, most of the tweets got classified as neutral because people generally tweet in a neutral fashion when it comes to companies. So what we found out that positive sentiment was highest towards Qualcomm, neutral sentiment was highest towards Broadcom, and negative sentiment was highest towards AMD, and least negative people were least negative about towards Nvidia. Now the exploratory data analysis using the TUI module and a lot of APIs. So what we found out, Nvidia has the largest following on Twitter. MediaTek came extremely late on Twitter, and the first account was created by AMD. AMD though had the second highest number of following. So Broadcom also came quite late, and Micron Technology basically came in 2009. Is second after AMD in terms of age, but their followers count is very less. Is the least basically. Also, number of tweets and retweets. So ARM is doing a good job here, but their following is not that good. Qualcomm is also second, but their following is good. Like it's 5 lakh Twitter followers. MediaTek, it was a newer handle, so it did not have much following. It was not tweeting and retweeting much. Number of likes by companies. So Nvidia is liking suboptimally other people's tweets. Qualcomm is liking ferociously other people's tweets. Broadcom is not liking at all other people's tweets, and MediaTek is also less here. Again, number of accounts followed by other by the companies. So basically, Qualcomm is following a lot of other people also on Twitter. Here also, Nvidia is not following anyone, almost 44. AMD is also not following much people, and MediaTek is following quite a bit of people. So basically, Nvidia, if you see, they are not the oldest account. They're not retweeting much, but still they have highest following. Similarly, this is the location. So most of the companies are located where they are headquartered, and their Twitter account is also reflecting that. Now, this Ukraine-Russia war problem, what we found out that when we basically use a data set and we labeled it with text blob and then we oversample it, we got the best results. So we did a comparative analysis here. So if we see here, so we took an example. Ukraine is standing strong against Russia. So what we found out, the accuracy, precision, recall, and F1 score was highest towards text blob when the data set was labeled using text blob and oversampled. So similarly, when we see the matrix here also, so the confusion matrix looks good. Whatever is negative is classified as negative. Similarly for neutral and positive. And if we see the model accuracy and loss curves also, so around 15 epochs or 20 epochs, basically accuracy, validation and training curves are giving good results. So in the future scope, basically what we want to do is we want to collect larger set of data for Qualcomm, Broadcom bid as well as sentimental analysis among four major companies. We want to analyze a lot of things like ARM is tweeting a lot, but they are not having following. Why is that the case? What their PR team is doing. Nvidia is not doing good in tweeting, retweeting, liking other people tweets, following other accounts, but still they have the highest followers. MediaTek, basically their engagement is not optimal, but still they are doing better than ARM, Broadcom, and Micron Technology. Similarly, for Ukraine-Russia problem, we want to explore other algorithms apart from bidirectional LSTM, and we want to basically manually train the label the training data set to find out how the results are being affected. So that's all from my side. Thank you so much.